start the statistics chapter. This chapter is going to be way different than all the other chapters we've done in Algebra 2. There won't be any factoring or graphing of functions or solving equations. This is kind of the basics you would see in a probability and statistics class. We'll start here with, I have two data sets. I have a first block and a second block, and let's say I gave a test to first block and second block, and I only had 5 kids in each class, just to make it easier. And these are the grades that those kids earned in each of those classes. So what we normally would do, and what you've done before, is we could figure out the mean, median, and mode. So before we do that, though, if you just look at the data sets, and you were me as the teacher, which class do you think did better on the test? So you probably have an idea at this point, so let's go ahead and figure it out and see what you think based on the mean, median, and mode. All right, so for the first block class, the mean, if I add them all up and divide by 5 in this case, I would get 86. So their average was an 86. The median is the middle number, so if I put them in order and then find the middle number, so I would have to order them. So like for first block, 74, 77, 83, 98, 98. And then pick the middle number, that would be 83. And then the mode is the one that happens the most, and in this case, that's 98. All right, let's go over to second block. And you can see that if I add them up and divide by 5, I would get 86, so just like first block. For the median, put them in order, figure out what the middle number is, I would get 83, just like first block. And the last value here is the mode. It's the one that happens the most, and in this case, it looks like I got 3 83s, which is different than the first block. All right, well, it looks like I have the same median and the same mode. Well, does that kind of jive with what you thought about which class did better? According to these numbers, they're pretty much the same. But it definitely looks like one class did better. So let's talk about something else. And we'll talk about standard deviation. But before we do that, let's just fill in the notes up there. So mean, median, and mode can give us some information about our data set. However, they are limited in their usefulness. So the mean is the average. And that's a pretty good predictor of, different data sets. The median is the middle number, a little less important, and the mode is just the number that happens the most, which, if I have 100 numbers in my data set and I know that 36 happened 3 times, that doesn't tell me that anything about the other 97 values in the data set. It just describes the value that happened the most. So there are some limits to mean, median, and mode. So we're going to add a value here called the standard deviation, and the standard deviation is a measure of the dispersion of a data set. In other words, it's how spread out the data is. So the higher the standard deviation, the more spread out the data is. The lower the standard deviation, the less spread out the data is. So the more tightly packed all my numbers are around the average, that's going to be a lower standard deviation. If my numbers are way spread out around the average, then I'm going to have a higher standard deviation. So if I come back here to my 2 data sets and I say, well, which class had the lower standard deviation? I would say for sure in this case it's second block, because the numbers are more tightly packed around the average. So my average or my mean was 86. And notice for first block, I got some mid 70s, I got some high 90s. But in second block, they're all pretty close to 86. So my standard deviation for second block here would be much lower than for first block. So second block had the lower standard deviation. And that's probably what you used to figure out that first time when I asked you which class did better. You probably just thought, well, second class is, a lot of their values are higher and they're more closely around the mean, even though you probably didn't think in those terms, but, it probably just looked that way. So we're going to use this standard deviation going forward a lot in this chapter. All right, so go ahead and pause the video here for a second and just copy these notes down. We'll do this in class. This is how you find standard deviation in the calculator. All right, so we have a term called outlier. An outlier is an observation that's numerically distant from the rest of the data. In other words, it's pretty far away from everything else in the data set. So outliers are normally considered to be values that are more than 2 standard deviations from the mean. The example I'm going to use is Usain Bolt. Usain Bolt is crazy fast. He's a track star. He won the 100-meter dash 3 Olympics in a row, and he finished meters ahead of all of his closest finishers. And that just doesn't happen in a 100-meter dash. So he is far away better than everybody else. So he is an outlier. So we're going to study that in terms of numbers here. So we're going to do an example here. And in 1961, Roger Maris made baseball headlines by hitting 61 home runs, breaking a famous record held by Babe Ruth. Here are Maris's home run totals for his 10 seasons in the American League. So would we consider his record-setting year to be an outlier? And his record-setting year is this one right here where he hit 61 home runs. All right, so before we do any of that, we need to figure out what the mean and the standard deviation are. So I'm going to tell you what the mean and standard deviation are. So the mean, and I'm going to use X bar for mean. X bar in the calculator, it will say X bar. Sometimes you're going to see it written as a mu, which is like that. It's a Greek symbol. It's not a U. It looks like a U, but it's mu. But the calculator uses X bar, and X bar is 26.1. So his average home runs for all the 10 years here is 26.1. The standard deviation, which in the calculator is sigma x, and the sigma is a Greek symbol again. It looks kind of like a whistle. The sigma is 14.8 home runs. So that's his standard deviation. All right, so if I know his mean and his standard deviation, what I can do here is draw a number line. And I'm going to put the mean in the middle. So the mean is 26.1. And then I'm going to go by standard deviation. So I'm going to add a standard deviation to that. So 26.1 plus 14.8. So that's going to be 40.9. So that's one standard deviation above the mean. And if I add 40.9 plus 14.8, I would get 55.7. So 55.7 home runs is 2 standard deviations above the mean. So again, in order to get these blue numbers, I added 14.8. I added a standard deviation to the mean. So I added 1, then I added another one. So I'm 2 standard deviations above the mean. Now I can go 2 standard deviations below the mean as well. So 26.1 minus 14.8 would give me 11.3. Now, if I subtracted 14.8 again, I would actually end up in negative territory, and I can't hit negative home runs, so I'm just going to put a 0 right there. But really, we're not concerned about below the mean. We're concerned about above the mean. So 61 would be right there. It would be above 55.7 on my number line. So since 61 is more than 2 standard deviations above the mean, so there's one, there's another. So since I'm more than that distance away from the mean, then that means this 61 is an outlier. It's more than 2 standard deviations above the mean. So what that means is, what happened in that year that he hit 61 home runs? It was a lot different than all the other years of home runs that he had hit. So why did he hit so many home runs that year? Well, that's what you use statistics for. You try and determine why something happened based on a data set. But really right now we're just concerned about whether or not that was an outlier. In this case, the answer is yes, it was an outlier.